Today's video, before we leap into the world of using a lot of the DevOps tools, there's kind of a fundamental that we haven't talked about yet that I really want to look through. And that's how computers talk to each other over a network. And that means thinking about IP addresses, DNS names, ports, that kind of thing. Um, so I want to be able to understand what IP addresses are, where you would find them. We might talk a little bit about the differences between IP version 4 and IP version 6. We want to be able to recognize certain patterns in those IP addresses, and we'll only probably talk about IP version 4 there. Recognize what private IP addresses might be, what public IP addresses might be, and how we find those on our machine, and what our network looks like. Okay, so those are the kinds of things we're going to do. So in terms of, you've got a computer like the one we've got in front of us here, and we can see that it's connected to the internet. You know, my machine is talking to other machines out there on the internet. We can see that down at the bottom right on Windows, we can see a network connection, and that's cool. So we're obviously on a network, but how do the machines actually talk to each other? Well, the first thing is machines don't like names, they like numbers. So if you've got a properly configured network, every machine on that network will have an IP address. And we're talking about TCP/IP here. I'm not going to go into the old world of other networking. It's been predominantly, in my career, it's predominantly been TCP/IP, IP addresses, that kind of thing. So every machine has to have a unique address to come back to or to go to. So what we do is, what does an IP address look like? So let's go through the basics. I'm going to do a bit of drawing here. So what does an IP address look like? So an IP address typically looks like 4 numbers with dots together. So an example would be 192.168.1.1. Okay, so we've got 4 dots here, and each one of those numbers, each one of these numbers here, those numbers can be between 0 and 255. Okay. Now, typically, when you plug in a computer onto a network or when you're doing Wi-Fi, there's a process in the background called DHCP, which we're not going to worry about too much, but that service that goes on in the background when you connect to your home Wi-Fi, that's issuing out IP addresses and keeping everything unique so that the computers don't clash. Okay. How can you tell whether or not 2 machines are on the same network? So if I had that first IP address is one machine, and then we have another one that's on 10.2.3.4. Now I can see with my experienced eyes that they're probably 2 different networks. But I can't without another bit of information, that's only an assumption. Okay, so there's a different thing called a subnet mask, which typically looks like 255. It's another 4 sets of numbers, and those 4 sets of numbers help carve up the what we call the IP address space. So with this subnet mask, what that's saying is anything that's got the first 3 numbers, that's all in the same network. Okay, there's a whole load of binary calculations going on in the background, but I'm not going to go through those. I'm not that experienced to go through those. Just know that the subnet mask and the IP address together define a network. And therefore, this number here, this 1 on the end, that if that any number between 1 and 255, they belong on the same network. Okay, so in terms of with those two bits of information, I can definitely say that 10.2.3.4 is not on the same network as 192.168.1.1. Okay, and what does that mean in the real world? Okay, well, let's flip back to our computer. So here's our computer again. Remember, I do a lot of work in the terminal, so I'm going to open up my terminal window. And here on Windows, we've got a couple of commands we can use to print out, like show us what the IP address of this machine is. So if I do a ipconfig, that will show me, it'll show me I've got more than one IP address, and that's because on this machine, we've installed things like VirtualBox, and we've got like Windows Subsystem for Linux, and they use their own IP addresses. But in terms of our home network, this is the definition of our home network. And here you can see we've got an IP address and we've got a subnet mask. Okay. So just like in the example that I wrote down on the whiteboard, my home network has a 192.168.1 network because it's got that subnet mask on. So anything that's between 1 and 255 is a valid address inside my network. Okay. Now, I didn't mention the default gateway. That is a third bit of information about my network, and that's telling Windows or any computer how to get out of my network, so how to go on the internet. So any traffic it doesn't recognize that's inside my network, it will send that to the default gateway and off into the internet. Again, I'm not going to go into that because that's beyond the scope of my beyond the scope of these lessons. So, this is just like a starter for 10 for how networking works. So we've looked at how what an IP address looks like, how we can find out that IP address. We can do so if you have Linux machines on your computer, if you use Linux or Macs, you can do the same sort of thing on there. If I just bring up a Linux example. So this is a Linux box I've got, and commands are slightly different in that if I do IP address, there you can see I get a whole host of different information, and this machine that I've connected to has lots and lots and lots of different IP addresses, but I can see here, I know that this is that's another computer on my network, and you can see the 192.168.1.124 there. So that's my IP address of that machine. Get rid of that so we don't get confused. Now, how can I test the connectivity between one machine and another? Well, if you remember, well, not if you remember, but when you've got submarines going around in the ocean and they're using sonar, they often ping each other or try and ping each other. So there's a command called ping, and it's actually short for Packet Internet Groper. But in terms of, I always remember it when I'm relating to sonar and submarines. Now, if I do an IP address that I know exists on my network, and I do ping that IP address, then I can see the output of that command is pings coming back. So these are replies from that remote machine. Okay. What happens if I ping something that I know doesn't exist? This is going to be a pure guess here. Well, then I get nothing. Destination host unreachable. Can't see it. Okay. So if we go back to that ipconfig, you can see here that you've got this thing. So we mentioned IP version 6 versus version 4. Now, we're not going to go into too much detail, but I just want you to know that they exist. IPv6 addresses have this format, which is 6 numbers in hexadecimal. So these are all hexadecimal numbers split by colons. And the reason why IPv6 exists is because there's only a limited number of IP addresses, both in the IPv4 and the IPv6 systems. But because we're using hexadecimal numbers and we're using 6 of them, the address space, the number of addresses we can actually have is massive compared to IP version 4. And there is a very slow movement to using IP version 6. You just need to know the different, these are IP addresses, they're just in a slightly different format compared to the IPv4 ones. Most of the work that I do when I'm troubleshooting networks is on IP version 4. So I don't generally worry about IP version 6. Okay, so the difference between public and private IP addresses. Okay, so this is a bit of pattern matching here. And so there's a concept out there of something called network address translation. And what that does, it protects I can have as many IP addresses inside my own network, and they can be unique inside my network. And then using network address translation, this gets around the limits of the IP address, the number of IP addresses limitation of IP version 4. So I can have as many IP addresses inside my network as long as my default gateways and subnet masks are all working in the right way. I can have as big a network as I want inside, but then if I want to get out onto the internet, I need to start using public IP addresses. So there's a concept of public versus private IP addresses. And if I just flash this up in a notepad, in my notepad here, right. So here you can see, here's the format of private IP addresses and private IP addresses. So you can see that most private IP addresses usually sit within 192.168 or 10.x.x and 172.16 to 172.32. Sorry, 31. And that's a guide for people who support networks. It gives you an idea of how big the network that you're on just by sticking to that kind of system. So when you want to go out of the network, let's have another example. I know a couple of public IP addresses just off the top of my head. Let's see if they're up. 8.8.8.8. So that is a Google DNS server. You don't need to know why that is. It just is, and it's nearly always up. There's also 1.1.1.1, and those IP addresses, they're going out it's going through my network because Windows knows that it's not on my network. It's then going out via the default gateway and then goes off into the internet and routes on the internet. I cannot route to another private IP address out there on the internet. They don't exist out there on the public internet. If you want to connect two home networks together, you have to do fancy virtual private networking or VPN stuff, which we're not going to do. And that's some of the protection that is given to you by being sat in a private network at home. Nobody can route into your network unless you open up your network to in a bad way. And most people won't even know how to do that. Most internet routers that you get sent to by your internet service provider, they're not going to let you do that because they know that would open them up to trouble. So we've had a quick look at public IP addresses. Here you can see the form of the public IP address. It's exactly the same, 4 digits, but they're not. Public IP addresses do not live in the 192.168 or the 10.x.x space or the 172.16 space. Okay, so that's IP addresses in a nutshell. But human beings are not very good at numbers. IP addresses prefer names. So how does that work? How does me typing google.com in my browser? Well, what happens there? There's got to be something in the middle that enables me as a human to put a name in, and then for the computer to be able to work out, oh, how do I get there? What IP address do I need to go to? Because that's what's happening under the hood. And that's where the domain naming system comes in. So we're going to talk about how DNS resolves. So DNS is the short name for domain naming service. We're going to use some basic DNS tools, troubleshoot a couple of simple DNS issues. So we've got our IP addresses and we want to relate them to names. So it's a bit like a contact list. It's a bit like a phone book. Okay. So that's, ultimately that it's a big phone book out there in the sky. And if you type in a special version of ipconfig on Windows, we can see, if we just go back, there's more information comes out with that. If you do an ipconfig all, more information comes out. And here you can see some more IP addresses have popped out. And those IP addresses are of DNS servers. So they're my phone contact lists. So if I were to do ping www.google.com, there you can see I get a public IP address. Public IP address of 142.251.29.105. That's going by. It's going to my DNS server that's sat there. Your numbers might be different. So there's an initial response to say, right, I've got a name for www.google.com. Do I know what that IP address is? If the Windows machine doesn't know what IP address it is, it then goes to this 192.168.1.79 server and goes, can you give me the IP address of www.google.com? Okay. So, well, how does that work? Can we narrow that down a little bit more? Let's do a bit of a diagram then. So our browser, we're going to type www.google.com into a browser. How does that turn into the IP address number? So what we do is, so we've got our wrong pencil there. So what we do is we have our computer here. This is me. And then out there on the internet, we have a DNS server. And we have multiple DNS servers. And then we also have, at the end of here, we've got www.google.com. Okay, so if my internet DNS server is that IP address, so if my machine doesn't know how to get to www.google.com, the first thing it'll do is it'll check its own cache. If it can't get it from cache, it will then go to my DNS server. If my DNS server doesn't know how to get to it, then my DNS server goes to the .com internet root into the internet root. They're called the root servers. Actually, that's not .com. It's the dot. So in terms of internet IP, internet names, we've got www.google.com dot. There's like a hidden dot there that automatically gets filled in. Then if the internet root server then will know how to get to the .com TLD DNS servers, and then they will know how to get to the Google. And then you've got the authoritative DNS server. And that would get you www.google.com. So we're gradually building up the address, or gradually getting to the point of the server that will actually know where the final IP address is, and then that will respond all the way back to our machine. So then it will get an 8.8.8.8 and be able to make the request to www.google.com. Okay, so let's flip back to our machine. How do we interact with DNS just on my local machine? So the most important commands for me are ipconfig/all, because that will show you the IP address of the domain name servers that I'm going to go to. So I need to make sure they're valid. Most of the time, these are automatically configured for you, but when you start looking after computers, you might have your own. On Windows, if I wanted to just look up an internet address, I could do an nslookup, and the nslookup so that's saying I'm going to go to my local DNS machine, see whether or not I can get the answer, and then this is the answer that's coming back for all of the different various IP addresses for google.com after doing that long request that we showed just then. And then kind of flushing caches, because that's often a problem. If we do a flush DNS, Windows keeps a cache of all of the DNS names it's gone for to save time. Sometimes you need to flush that cache. That's a really important tool, but it doesn't do much on this machine, particularly because I'm not running as an admin at the moment. Okay, so now we know how Windows and how other computers relate IP addresses to names. So that's good. Now we're going to think about ports. So what does a port do? So ports are how you share different if you're hosting different services to be offered out to different people. Ports are how you don't waste IP addresses, because IP addresses are limited. There are various ports that are recognizable. There's lists of ports. Web servers typically are on port 80. Again, this is hidden from you, but like if I go into a browser and I open up a new tab, if I went http www.google.com port 80, that would go to the port 80 of www.google.com. That's hidden away from you on a browser because just because it's the same on every machine, so why show it to everybody? But that's what's going on under the hood. All right, so for every IP address, there are 65,536 ports. And they can be configured to be whatever you want, but there's standards out there that generally define various different services sit on different ports. So for example, oh, what's that name? For example, we can show, like if I go to this is the IANA port list. This shows you the standards for various different ports. So if I put in port 80 search, it shows you, well, generally it's HTTP there. 443 is another common one in the DevOps space. And that's HTTPS, so that's secure HTTP, but it also hosts other things. So, this website shows you all of the different ports. 53 is DNS. There's SMTP. There's all sorts of different services. What does that mean on my machine here? So if I wanted to start a web server on my machine, and we've installed Python, and you can make Python do a simple web server that just shares the local folder that it's in. How would I do that? What does that look like? So Python -m http.server. And here's where I specify the port number. So this is, I want to host a HTTP server on port 8000. I can put it on any free port that I want to. 8000 is just a random number that I've come up with. And then once we start that, then you can see, oh, I'm serving on port 8000. Now these colons, that's saying by default it's hosting on IP version 6 in my brain. You might see, if you haven't got IP version 6 running, you might see 127.0.0.1, and that's a special IP address for the local machine called localhost. Or you might see 0.0.0.0, which means connect to or host this service on every IP address on port 8000 on my machine. And if we were to go HTTP localhost port 8000, there you can see the machine that I'm on. This is the folder structure, and you can see that it's responded to a request here. Okay, so that's an example of a server running on your machine. So if I exit out of that, I guess the last thing to really think about with ports is, well, how do I find out which ports my machine is currently listening to so I don't try and reuse them and cause myself errors? There's a special command called netstat, which dumps out all network connections on a Windows machine, in and out of it. If I do that, I can see lots and lots of communication, but the ones I'm interested in are these listening ones. So what's listening? So we can pipe that command, the results of that command, into a different one. So find straight is going to find me all lines that contain the word listening, and that /i is case insensitivity. So if I do that, that shows me a list of everything that's listening on this computer by default. This is a fairly new Windows install. Here we can see 135.445 are usually to do with Windows file sharing. 139 is another Windows file sharing port. 3389 is remote desktop, so I'm using remote desktop to get to this machine, so 3389 has to be listening. And there's a whole host of other ports as well, which in the Windows documentation you could go and find if you needed to. So there's not much listening on this machine. At this point, you just install software or you'd write applications to be able to listen out on ports, and that's how you start to think about network connectivity. And that gets us more or less ready for starting to think about Docker containers and Kubernetes, because there's a lot of networking that we have to pay attention to for this to be useful. So hopefully that was useful. Like and subscribe helps the channel grow, keeps me going, and we'll see you later for the next lesson.